Using a mux, you can design any other logic circuit. For example, suppose if you want to design a NOT gate, so using a mux, you can design the NOT gate. So just now I'm taking one examples for a NOT gate. NOT gate, NOT gate. So suppose here this is a 2 is to 1 mux. 2 is to 1 mux means two input I naught and I1. This one is the two input and one selection line and one output. So what is the value of y? And suppose this selection line is a. So this is the selection line, two input I naught and I1. And suppose that I naught is equal to 1. I naught equal to 1 and I1 is equal to 0. So what is the logical expression of this one? So this is equal to, here you have write down y equal to s bar I naught plus s into I1. Yes or no? Or you can put here the logical expression. What is the value of S bar? So S is denoted by A. So you can write down here the A bar and I naught is equal to 1 into 1 plus S equal to A and I1 is equal to 0. So what is the expression? So Y equal to A bar. So this is work like a NOT gate. This one is work like a NOT gate. Is that clear? So mux is work like a NOT gate, y equal to y bar. Similarly, so anyone have any questions in these sections? Yes, give your response. Yes or no?
No, sir.
No,
Okay.
sir.
Second, someone say how the mux is work like a AND gate. AND gate. So just now I'm saying this is a mux. So using a 2 is to 1 mux, suppose this is a 2 is to 1 mux, 2 is to 1 mux, 2 is to 1 mux. So one input, this one, another input, two input, one output, y, and one selection line. So this selection line is S, and input is I naught and I1. And now, suppose that this selection line is A, and here the input is 0 and b, 0 and b. So what is the output? So output is where you have write on the output s bar I naught plus s I1. Yes or no? So this is the final expression. So what is the values? So just to put here the value of s bar means a bar into I naught is 0 plus S is A into I1 is B. So what is the expression for y equal to AB? Y equal to AB. So this is AND gate. AND gate. Yes. Anyone have any doubts? Yes. And for suppose if you want to represent this one is an AND gate. So this is a 2 is to 1 mux. 2 is to uh, just you have writing here 2 is to 1 mux. So 2 is to 1 mux. One is the input I naught, another input I1, and one selection line. Suppose this selection line is A. Selection line is A, and here I am drawing the output that is equal to Y. And this input is just for the AND gate, just invert. This value is 1, and this input is B bar. B bar. Yes. So what is the output here? So this is equal to S bar I naught plus S I1. So what is the value? S bar means A bar into 1 plus S is A and I1 is B bar. Or you can write down this values is equal to A bar plus A B bar. or you can write down this is equal to a bar plus a into a bar plus b bar, or what is the value of a plus a bar, that is equal to 1 into a plus b bar, that is equal to a into b whole bar. This is through a De Morgan's, and this is equal to a b bar. So this, what is the expression? So this expression is work like a NAND gate. NAND gate. So a mux work can be designed AND gate, or NOT gate, OR gate, XOR gate, half adder, full adder, half subtractor, full subtractor. That's why this mux is called a universal logic gates. So suppose I want to design the OR gate. So how the mux work like a OR gate? How the mux work like a OR gate? So suppose this one is 2 is to 1 mux. 2 is to 1 mux means two input, I naught, I1, and one selection line, and here the output, that is equal to Y. And suppose input is equal to this selection line is A and input is B and 1. So what is the expression for the output? This is equal to S bar I naught plus S I1. So what is the value of S bar? That means A bar I naught is B plus A into 1. So this value is equal to A bar B plus A. And what is the value? So this is equal to A bar plus A into A plus B. And what is the expression for this? This is equal to 1. So this is equal to 1 into A plus B, or this value is equal to A plus B. Work like a OR gate. So this is OR gate. OR gate. And suppose if you want to uh, design a NOR gate, so the mux the input is 2 into 1, 2 into 1 input, one selection line, and one output. So that output here this is the 2 is to 1. So again 2 is to 1 mux, 2 is to 1 mux, and this is I naught, I1 selection line, and this uh, selection line is equal to A, and for a NOR, just it's a bar, so this value is B bar and 0. So what is the output here? So this output is equal to uh, S bar I naught plus S I1. So what is the value of S bar? Means A bar is equal to, so up to this point, anyone have any doubts? Yes. Yeah, anyone have any doubts? Yes. So what is the value here? Just a value is as A bar I naught is B bar plus A into 0. So what is the value? This is equal to A bar into B bar, and this is equal to, apply the De Morgan's law, and this is equal to, so what is the value of this? Yes, A plus B whole bar, and this is called uh, NOR gate. NOR gate. So up to this point, anyone have any doubts, any query? Yes or no? Is that clear? Or anyone have any doubts? Everyone give your response. Unmute your mic and give your response. Is that clear?
No, sir, no doubt.
Clear,
So
sir.
can you design
Yes,
the
sir.
mux work like XOR or XNOR? So just everyone try it. How to design the mux using like a XOR or XNOR. So just suppose now I'm discussing how to design this XOR logic gate. XOR logic gate. So this is a 2 is to 1 mux. This one is the 2 is to 1 mux. 2 is to 1 mux. Having a 2 input, one selection line, and one output Y. So what is the input? Input, just I'm taking here A is as the input. That is the fix. And now what is the value of this? So this one is a B and B bar. This one is the input. So what is the output? Output is equal to A bar into B plus again A into B bar. Yes or no? So what is the value of this one? So this is I naught, this one is I1, and this one is the selection line, and here the output. So here I am writing S bar I naught plus S I1. So can you write down this expression? What is the value? So this value is equal to A XOR B. So you can say this is a XOR logic gate. Similarly, someone designed to XNOR. So how to design the XNOR? So suppose this is a 2 is to 1 mux, 2 is to 1 mux, having a 2 input, 1 on output, and so this is the 2 is to 1 mux. And here the selection line, that values is A and XNOR. So just invert these values. So this input is B, and this one is B bar and B. And what is the output? So output is equal to S bar I naught I1, I naught plus Si1. So A bar B bar plus AB. So this is called AX nor B. Is that clear? Or anyone have any dots, any query? So, so can you design the mux using a mux? You can design a half adder. You can design a half subtractor, full adder, full subtractor. So up to this point, anyone have any doubts, any query? Yes. Anyone have any doubt, any query? So when you have some important points, so when you have design AND gate, when you have design OR gate, when you have design NOT gate. So in this case, required 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 uh, one two is to required 1 2 is to 1 mux, required 2 is to 1 mux, 1 2 is to 1 mux. But when you have designed the NAND gate, you have designed the NOR gate, you have designed the XOR gate, you have designed the XNOR gate. So you have a required, in this case you have required uh, 2 2 2 is to 1 mux, 2 is to 1 mux is required. Yes. Suppose is it mandatory to only you can design a using 2 is to 1 a NAND gate or NOR gate? No. So using a 4 is to 1 mux you can also design other logic gates. For examples uh, for examples suppose this is 4 is to 1 mux. This is a 4 is to 1 mux. So 4 input I naught, I1, I2, I3, and then the selection line. Just now I'm taking a selection line. Suppose A and B is a selection line. So this is simply not the S naught or S1. And finally output, one output, that is Y. So this is a 4 is to 1 mux. 4 is to 1 mux. So 4 input is just like the 4 input is 0, 0, 0, and 1. So what is the output of this expression? So output of this expression is, what is the output of this expression? So simply the output is expression is equal to A bar B bar I naught plus A bar B I1 plus A B bar I2 plus A B I3. And what is the value? So this is 0 0. So you can say the 0 plus 0 plus 0 plus AB. So this value is equal to y equal to AB. So it's work like a AND gate. and and gate. Is that clear, or anyone have any doubts, any query? So everyone understood, or anyone have any doubts, any query? Everyone give your response. So similarly, you can design the OR gate, NOR gate, NAND gate like this. So can you design the other logic gates using a mux? Yes, yes or no? Everyone give your response.
Yes, sir.
Anyone, those have any doubts, any query? So questions is determine minimum determine minimized logical expression for a given mux circuit. So your mux is like this one. This one is 4 is to 1 mux, having 4 input. How many selection line? 2 selection line and 1 output. So what is the output? And input is just like I naught, I1, I2, I3, and the selection line. So S naught or S1, that values is equal to A and B. And its the values is, suppose this is C bar and this values is C. So what is the value of Y? So everyone find it and write down your answer in the chat box. So what is the value of Y? Determine minimized logical expression for a given mux circuit. So what is the logical expression? So that is equal to, yes, write down like a S1 S naught bar. Its the values is I naught plus S1 bar S naught I1 plus S1 S naught bar I2 plus S1 S naught I3. Yes or no? So what is the expression? So what is the value of S1 bar and S naught bar? So simply you can write down that is equal to A bar, B bar, and what is the value of I naught? I naught is C bar. Again plus A bar, B, I1 is again C bar plus A, B bar, I2 is C plus A, B, C. Or what is the expression? Just to see that here, A bar, C bar is common. So A bar, C bar is common. So it's the values is B plus B bar. And again here, AC is common. So the values is B plus B bar. And B plus B bar is 1. So A bar C bar plus AC, and this is equal to AX nor C. So finally its a logical expression is AX nor C. So this is 4 is to 1 mux. Okay. Now I'm discussed to some other type of questions like this one. So this is also a very important. So implementation of given logical expression expression using a multiplexer using a multiplexers. Okay. So example implemented implement implement function a b and c is equal to mean of 0 1 3 6 7, like this one. So this is very important. Mean of this one using using 4 is to 1 marks using 4 is to 1 marks with AB as a select line select line where AB is as a select line. So this is your questions, and implement this function using 4 is to 1 marks 1 marks. So how to solve these questions? Yes. So first, how many variables here? Three variables. So I'm taking a three variable number in the next slide. So just now I'm taking for a truth table three variables number. So A, B, and C. This one is a three variable number, and here given that the A and B is a select line. See that in these questions, here mentioned that A and B as a select line. So C is free. C is free. A and B is select line. So I'm draw here. We can write down these values. First write down like this value is 0, 3-bit number, 1, then 2, 3, 4, 5, 6, 7. So simply in the decimal number you can say this is 0, this is 1, 2, 3, 4, 5, 6, and 7. I'm writing this one, and here the values is given that. So A and B is a select line. So these A and B is a select line. Select line. So what is the value of C? Just to see that only these values. Only you have free for these values. So what is the value of 0? 0 is simply you can write down this one is like a C bar. 0 C bar. 0 C bar. Where is the 0? C bar. Yes. And in place of here 1. So in place of 1, you can write down here the C, here the C, and here the C values, and here the C values. Yes. Why I'm choosing C? Because A and B, this one is select line. Select line. So rest line is only C. That's why I'm writing. Then here I'm writing a implementation table. Implementation table. So how to draw the implementation table? So in the implementation table, the variables is one is C bar and another one is C. Just a simply I'm writing like this. One is so this is one is the C bar and another one is a C. And its the values is first I naught. I'm writing I1, I2, and I3. These values is given. Yes. So where is the C bar? In the place of 0, 2, 4, and 6. So here 0, 2, 4, and 6. Where is the C bar? In the 0, here C bar 0, C bar 2, 4, and 6. Just to see that C bar. And where is the C? So in the place of 1, 3, 5, and 7. Yes. So up to this point, anyone have any doubts, any query? Yes or no? So at least give your response. Everyone give your response. And then
Sir,
questions is where is the mean term? Where is the mean term? So mean term is available at the 0, 1, 3, 6, and 7. So just round up this sections. So round up this sections is 0, 0, 1, 3, 6, and 7. So this is the mean terms. 0, 1, 3, 6, 7 is the mean term. So here when the both having a round circle, then you can write down in this condition is 1, and when the only one is a round circle, 2 is not given. So in this case you can write down this values C, and both is not rounded, so you can write down this values is equal to 0, and both is round up, so it's the values is 1. So how to design the 4 is to 1 marks? So here the 4 is to 1 marks is, this is a 4 is to 1 marks, 4 is to 1 marks, having a 4 input, having a 4 input, 2 selection line, 1 output Y, and this input is I1, I2, I3, selection line S0, S1. So it's the values is A and B. Just I'm saying now, AB is a select line. AB is a select line, and then input the terms is, so I naught is, just see in this slide. I naught is 1, I1 is C, I2 is 0, and I3 is 1. So simply you can write on these values is 1, C, 0, 1. So this is the final answer. So up to this point, anyone have any doubts, any query, yes or no? Are you understood how to design? So in these questions, it may be AC is select line, it may be BC is select line. That one is mentioned in your questions. Suppose in the same question, suppose AC is select line, then you can write down here the term according to B. B. So B is B bar B bar, then B B, B bar B bar B B, like this type of expressions. I hope everyone understood. Or anyone have any doubts, any query? Is that clear? Yes.